Now we're going to look at the next question, 1.9.6, which is prove the sine rule using the vector product. So what I've done here is I've drawn us a triangle. We don't know any of the angles, we don't know any of the side lengths. I've labeled the angles theta C, theta B, and theta A. And on the opposite side of each of those angles, we have the vector A opposite theta A, vector B opposite theta B, vector C opposite theta C. Now, you can choose any direction you wish for which way they point, but it does affect your signs when you're working through the problem. I've chosen the directions as you can see here, and the first thing I want to do is I want to write B in terms of vector B in terms of vector A and vector C. So here we can say vector B is equal to vector A plus vector C. Because to get B, we go along A and along C. That's our first equation we need to write. Our next equation we want to look at is the magnitude of vector B cross vector A. Well, we'll look at the magnitude in a moment, but let's rewrite this, and instead of writing vector B, let's write vector B in terms of vector A and vector C. So we can now rewrite that as vector B, which is vector A plus C cross vector A. Now that we can use the law of distribution to say it's the same as vector A cross vector A plus vector C cross vector A. Because vector A is parallel to vector A because it's the same vector, that is equal to 0. Now here we've now shown vector B cross vector A is equal to C cross A. That's our step 2. Step 3, we want to now we want to write the cross product between vector C cross vector B. Now we've managed to get this in terms of vector C and vector A. Let's do the same with this one. So vector C cross vector B, which is A plus C. A plus C. Again, law of distribution comes out with C cross A plus C cross C. C cross C again is going to equal 0, so we can now say vector C cross vector B is equal to vector C cross vector A. So now we have vector C cross B is equal to C cross A, and we know C cross A is equal to B cross A. So now we can say B cross A is equal to C cross B, which is equal to C cross A. Now, if each of these are equal, we then know that the magnitude is going to be equal as well. So if we're looking at the magnitude of each of these, the magnitude for the vector product or cross product is magnitude of one times the magnitude of the other times the angle between them. So let's look at it this way. So we have B times magnitude of A times sine angle between them is theta c. It's going to be equal to c times b times sine angle between them. It's going to be, we translate that over to here, it's going to be this angle here. And we know by corresponding angles that will be theta A. And final point, we go C times A times sine of the angle between them. Between C and A, we were to translate that angle down to here, we would land up with this angle over here. Now, what we that angle would be equal to this angle here. What we know as well, because of the sine curve, is if we look at 90 degrees here, that the angle here is going to be the same as the angle over here. Because if it occurs on a point here, it'll occur on a point over here. Let me make that darker so you can see. So we can say that is going to be equal to sine of, it is C and A, sine of theta B plus 90 degrees. Is it? Sorry, 180 minus theta B. Theta B. Sine of 180 minus theta B is equal to sine of theta B. So now let's divide. I have now written these each just as magnitudes, so I don't need to put the vector symbol above. The two ways you can write it, as you know, are this or this. So now let's divide the whole equation, each part of the equation, by the magnitude of A times the magnitude of B times the magnitude of C. A, B, C. A, B, C. A, B, C. Let's do some cancelling. That cancels with that, that cancels with that. That, 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 that. And what you're left with is sine theta C over C is equal to sine theta A over A, which is equal to sine theta B over B.